back. We're in section 6.2, and now we're going to really focus in on quadrilaterals and specifically parallelograms. And so if you look at the top here, a quadrilateral with two pairs of parallel sides is a parallelogram. This is the symbol we're going to use. We're going to kind of do a little bit of a box symbol there, kind of lean it a little bit, make it look like a parallelogram. And so this is how we write parallelogram ABCD without writing out the word parallelogram. We're going to use that symbol right here. And this is what you notice in red, AB and CD are parallel to each other, and we show that with a single arrowhead, and then BC and DA are parallel to each other, and we show that with a double arrowhead. So that's how you distinguish between your pairs of parallel sides. So we've got a number of theorems that we have to look at, and this is what I want you to understand, and I'm going to circle the key part, okay? This is true for all parallelograms right here, what I've got circled. There's four things that we're going to try and remember about parallelograms. First of all, the opposite sides are congruent. So if you look at the first one here, you know, where we have a parallelogram, which means the opposite sides are parallel, that means that they are also congruent. They're the same distance away from the other set of parallel lines. So it makes sense that if they're the same distance away from the other set of parallel lines, that they in themselves would be congruent to each other. So AB would then be congruent to CD, and BC would then be congruent to DA. So it makes sense, I hope. Okay, so that's one thing we know about parallelograms. Their opposite sides are congruent. Okay, here's a second thing. In a parallelogram, their opposite angles are congruent. So in this one, angle B and angle D would be congruent because they're opposite of each other, and A and C would be congruent. Okay, so that's something else to know about them. Their opposite angles are congruent. Here's a third thing. In a parallelogram, their consecutive angles, that means we're not skipping any, they're next to them, the consecutive angles are supplementary. So when I add these two together, I'll get 180. When I add these two together, I'll get 180. These two, and then these two. Consecutive angles are going to add up to be 180. Sounds a little like same side interior, wink wink, okay? And then here's the fourth thing we need to remember, that in a parallelogram, their diagrams bisect each other. So you're going to form lengths that are equal to each other. So BZ and DZ are equal, and then AZ and CZ are equal. So that's what we know about them. So that's what we want to bring to this next page, this understanding that there are four things that are true about parallelograms. Okay, opposite sides are congruent, opposite angles are congruent, consecutive angles are 180 degrees total, right? Supplementary. And then the last one, that their diagonals bisect each other. That's what you need to remember is true about parallelograms. So I put that down in the margin just as kind of a reference, so when we work with example 1 and the check it outs, they're going to be right there for you to look at, okay, instead of flipping back and forth. Plus, this is a really good thing to put, you know, on your Chromebook, is to create a file about parallelograms. This is true about parallelograms. And so these are some things to write down. All right, so let's take a look. The diagram shows the parallelogram-shaped linkage that joins the frame of a race car to one wheel of the car. It forms a parallelogram. So in parallelogram, PQRS, QR is 48 centimeters, RT is 30 centimeters, and the measure of angle QPS is 73 degrees. We got to find each measure in A, B, and C. So let's start with A. We'll start right here. PS is right here. I just circled that on the drawing, and probably should have circled it in white to make it stand out. Now PS in this parallelogram is opposite of QR. QR we know, and we know that they're congruent because of the very first one that we learned, which was, hey, if you got a parallelogram, their opposite sides are congruent. So if QR is 48, then so is PS, okay? So PS is equal to 48 centimeters, okay? So that's just using logic. We didn't really have to calculate anything. We're using our knowledge of parallelograms to figure this out. All right, letter B, the measure of PQR, angle PQR. So that's going to be this big angle right here, okay? Angle PQR. We got to figure out what that angle measure is. Okay, well, what do we know? Well, we know QPS. We know that this one right here, we know that that whole thing is 73 degrees. QPS, the whole thing is 73 degrees. So look where the positioning of angle PQR and angle QPS, look at their positionings, okay? They're same side, interior basically. They're consecutive angles, and we know that together, one I know, one I don't, are going to add up to be 180 degrees. So here it becomes a little bit of an algebra problem. We're going to take away 73 from each side, and that missing angle, which is the measure of PQR, is going to be the difference between 180 and 73. Okay, so it looks like it's 107 degrees total because they're going to end up being supplementary. Okay, hopefully you're like, whoa, that's simple. All right, and then finally, let's look at letter C. We're trying to find the length of PT. Now let's look at what we know. We know RT is 30 centimeters, and we know that RT and PT are congruent because of number 4, the fourth theorem that you learned, which is, hey, in a parallelogram, the diagonals bisect each other. So if you know RT, which is 30 centimeters, then PT is also 30 centimeters. So that's what we know. And that's just using our knowledge of parallelograms. All right, 1A, 1B, 1C. These are for you, 1 point each. See what you can do. Out to the side, do a justification of either theorem 1, 2, 3, or 4, if you will, please. Just to keep your mind fresh on these things, that these are theorems and we want to apply them. Okay? Bring your questions to class.